Here in the try class, we need a new method, public list of strings. We call it find words and give it a prefix. Now the first step here is to find the node for the last letter of this prefix. So if the user types car, we want to go to this node because all the words we're looking for hang off this node, right? So back in the try class, finding the last node for this prefix is going to take a few lines of code. So I would prefer to implement that in a separate private method. So private node find last node of this prefix. Now the algorithm we need here is very similar to what we had in the contains method. So we start from the root node and we visit each node for each character of this prefix. So we declare the current variable and set it to the root node. Now we loop over all the characters in this string. So for each character, in prefix.toChar array, we ask the current node for this child. Now, if the child is null, we want to return null. That means we don't have this prefix in our try. Otherwise, we set the current to this child. Finally, at the end of this loop, current will represent the last node for this prefix, so we return it over here. Okay, pretty straightforward. Now that we have this method, we can go back to our find words method. We get the last node for this prefix. And now we're ready to kick off our recursion. So we need another private method for doing the recursive work. Private void find words. We give it a root node, a prefix, and a list object for collecting the words. So as we're calling this method recursively, we'll populate this list with the words that we discover. So back to our public method. Here we need to create a list of strings. So list of string, we call it words, and set it to a new array list. So just to refresh your memory, list is an interface, array list is an implementation of that interface. We talked about this in the first part of this series. Now we're ready to kick off our recursion. So we call find words, give it this last node. We start from here. We give it also this prefix and the list of words. Once we're done here, we return the list of words. That is the big picture. Now let's implement this recursive method. That's very easy. So here we want to do a pre-order traversal, which means we should visit the root node first before we visit its children. So what should we do with the root node or the current node? We should check to see if this node represents the end of a word. So if root represents the end of a word, we want to add this prefix to our list of words. So we use this prefix to build up a word as we're walking down the tree. So here we call words.add and give it this prefix. Now we should visit the children of this root node. So for each child in root.getChildren, we recursively call this method. Here we go to this child node, and this is where we need to update the prefix. So prefix plus child.value. What does this mean? Well, if you're currently at the R and we're going to go visit the D, what is the current word at this level? It's card. So when we're at the R and we want to recursively call this method to go to the D, we should pass the current prefix, that is car, plus the value of the child node. Okay? Now, finally, we need to pass the list of words. Now let's test our implementation. So back in the main class, I've populated this try with these words. Let's call try.findWords, give it this prefix, store the result here, and then print it on the terminal. So we have car, card, care, and careful. Beautiful. What if we pass care here? We should only see care and careful. There you go. What if we pass card? So far, so good. What if we pass cargo? We got a null pointer exception. In a recursive method, we have to see if the root is null or not. If it's null, we're going to return immediately. So if root is null, we're going to return. Let's test this. Beautiful. One more test. What if we search for egg? This is working too. What if we search for E? Perfect. Now let's try C. We get all these words. Beautiful. Now let's try an empty string. We get all the words in this try. And finally, let's try null. We got another null pointer exception. Let me try to find the last node for the prefix. In this method, before we walk down the tree, we want to check to see if the prefix is null. So if prefix is null, we're going to return null. Let's run it one more time. Beautiful. So this is how we implement auto-completion.